Thank you very much for taking the time out and joining us today. And I'm sure all of you guys are big data enthusiasts and want to learn about streaming technologies. So today we thought we're going to share with you a unified in-memory fast batch and streaming technology platform that's developed at DataTorrent. Let me first start by introducing our speakers today. We have John Fanelli, VP of Products and Marketing at DataTorrent. John will take you through an overview of the platform and also followed by a live demonstration of the key features and functions of the platform. And we also have Lauren Segato, who's the Director of Corporate Marketing here at DataTorrent. Lauren will be managing your questions at the end of the session. Just a couple of logistics before we get the session started. We encourage you to submit your questions, and you can submit your questions via the question or chat box in your console, and we will take your questions at the end of the session. And then second, the session is being recorded. We'll be sending you the recording after the session so you can view it on demand or share it with your colleagues. All right, with that, I'm going to hand it over to John.
Great. Thanks, Shay. Thanks, everyone. I appreciate you attending. So the focus today will be on simplifying big data analytics and really talking about a unified batch and stream processing system. So for those of you that may not be familiar with DataTorrent, DataTorrent has built out a real-time platform that enables enterprises to process data in motion and to take action in real time. And the real focus of the design center for this product offering was that going forward in big data, not only would you have big data lakes, but those big data lakes would be fed by massive amounts of data streams. And so the platform was built to handle that data in a pipeline fashion at high scale with high performance and fault tolerance. Along the way, we found that there's an interesting phenomena in that many customers were using this data pipeline and processing data in motion for both batch as well as streaming use cases. And the reason that they're doing that for both use cases is that they're looking to get faster time to insight, which allows them to take action more rapidly. The result of this is that they're obtaining greater business value from their fast data. And many times people wonder, how can batch and streaming be used together on the same platform? That's sort of like cats and dogs living together. It just never happens. So let's take a look at the type of big data applications that we're seeing in the marketplace. There's many ways to represent big data applications. In this diagram, we're actually looking at a 2x2 matrix, where the first one on the vertical axis is around the data velocity. In fact, how quickly is the data being created, how quickly is the data moving, and how fast is the data able to be consumed. Across the x-axis and on the bottom axis, we're looking at the data discovery or the rate at which the questions are known. So for example, in the lower left corner, you have reporting. And reporting is typically done on data at rest. And you know ahead of time, of course, what your dashboard is going to look like, which questions you're going to use. Continuing to the quadrant on the right, when you're looking at data at rest where you don't know what your questions are, you're doing lots of data discovery, typically writing SQL queries, maybe writing Python scripts, doing those types of things, complex machine learning, etc., on data at rest. And then, of course, as you move up on the left-hand side, up the y-axis, you start to see that data velocity increase. In fact, many times in the telco industry, where we process CDRs, called data records, we see those records being generated in a batch mode, but every 5 minutes. So not necessarily streaming yet, but still not data at rest. Moving all the way up through, change data capture, operational analytics platforms, and certainly in financial services, things like fraud and threat detection, where you're looking at sub-millisecond latencies. And then, of course, even on those streams, you can do data discovery by doing SQL on those streams, or in fact, writing machine scoring or Java or Scala business logic to do discovery on the streaming data as it comes in. And what we found is that for 3 of the 4 quadrants, the stream processing and the batch processing, a data pipeline or a data in motion architecture works extremely well for both of them. And so that's the focus of our discussion today. And as DataTorrent was focused in on solving streaming application problems, we thought we'd start there, sort of the design center. And when you look at streaming data sources are fast data. This is where data is coming in from multiple sources. It's coming in at multiple rates, and of course, in multiple sizes. So very well-known use cases include transactional data, credit card processing, retailing, e-tailing, web click stream, so looking at visitors to your website, looking at advertising capabilities, and generating personalized offers. Clearly, mobile devices are generating a plethora of data, whether that be GPS data, usage data, cell phone data, etc. Your mobile devices are a walking, talking data emitter. And then on the data center side, of course, there's operational log files. And so these log files are being generated by your applications, by your network equipment, by your data center equipment. And these files are there to help you run your data center. And the ability to react very quickly to those is important to keep your data center up and operational. Now, newer data sources that are coming online are public data. So with a lot of governments and organizations now starting to share their data publicly, whether that be census data or weather data, we're able to take that data and use it to enrich it to make our applications and our particular use cases much more valuable. And then finally, sensor data, which is coming from manufacturing, from devices that are instrumented, whether those be planes, automobiles, medical devices, etc. So we have all these different data sources that are streaming in data at a very high rate, and in some cases at different times, every second, every millisecond, every minute, every 5 minutes. And what we see from our customers is that they're using these in many different instances where they need the hard and fast real time from an engineering perspective to kind of the definition of real time as being interactive and not being static. So, even the fact that you're listening to this webinar is in real time, and you joined us in real time, unless of course you're watching the recording. But in either case, we see a number of use cases such as real-time advertising, and I'll provide a case study for that in a few moments. We see customer service use cases where some data may come in off of a telephone call. You want to pull the caller ID. You want to use that caller ID to do a lookup into your customer database. Use that customer database to get a customer ID, which you then match as a key and enrich with customer purchase history and customer support history, so that when the customer service representative answers the phone, they can give you a personalized greeting and have much more context around the reason you're calling. Operationally, we see a number of different use cases, both at the enterprise level as well as at the telecommunications level. So, for example, with a telco provider who is operationally managing their network, to help them implement network function virtualization, or NFV, so that they can look for hotspots in the network that might need an extra boost and spin up additional capability to resolve either performance issues or to reroute around an outage. And of course, to spin those down as those issues are resolved. In financial services, the need to be able to look at a credit card transaction in sub-milliseconds to determine if that credit card transaction is in fact a fraud or a valid transaction. And more, especially in the IoT space, we're seeing this use case of predictive maintenance. And so using predictive maintenance to look at a device and decide if that device truly needs to come out of service. So many of us have cars where you're told to take your oil change in at 3,000 miles. And of course, we all drive our cars differently. So some of us may not need to have our oil changed until 5,000 miles. And some of us may need to have our oil changed earlier at 2,000 miles, depending on the use case. Now apply that to something like an airplane, where if you take an airplane out of service when it doesn't need to be out of service, that airline is losing the revenue that they would be generated by that plane flying. So that's never a good thing. And of course, if you leave something in service too long, that introduces all kinds of potential for maintenance issues and safety issues. So this is sort of the landscape around streaming. And what we found is that in a streaming environment, there's a common, consistent data flow that our customers provide. And this data flow takes the form of this diagram that you see here, where customers first will want to ingest data, and then they generally will want to archive that data for the future or for other applications. A subset of that data is being used in this particular application will move to the next stage of the pipeline, where it may be transformed, it may be enriched, and it actually may be normalized. So some data sources, as I mentioned, might come every 60 seconds, while some data sources might come every 5 minutes. So we need to figure out how we want to look at that data and how we want to normalize that. Once we have the data prepared in the way that we can analyze it, we then pass it on to the analytics phase, where the analytics could be everything from machine learning to predictive analytics to dimensional computing. And we want to enrich that analytics with business logic. So the idea is that on streaming data, as soon as you have an insight, you want to be able to programmatically, using business logic, issue the next stage, which is an alert, or take action, which in the case of the telco might be to spin up a new network function. And then finally, at the end of the pipeline processing, because again, your data is all in memory and is all in motion, you generally want to persist that data, and that data can be persisted into a number of data sources or even put on another message bus. And generally, there's a visualization aspect of the application you built. And that visualization may be operational in terms of how much you've ingested or how long the system's been running, or it may actually be visualizing as the results. You may be creating a real-time dashboard for metrics such as same-day sales or sales quarter to date. So this pipeline, we've seen this apply to pretty much every one of the streaming use cases. However, there are some key attributes that we bring to this pipeline that make it very successful and make it enterprise grade for our customers. Moving from large-scale data ingestion to high-performance in-memory processing that is fault-tolerant, scales linearly, and allows for custom business logic from a developer perspective, and is easy to use from a data scientist perspective, and is able to be operated from a data center perspective. And so all of these requirements are actually satisfied by the following architecture. So DataTorrent RTS is built on top of Hadoop 2.x and takes advantage of Yarn in HDFS. The core or the foundation of DataTorrent RTS is an open source technology called Apache Apex. And Apache Apex has two projects. The first is the open source, high-performing, fault-tolerant, in-memory data processing platform, which provides all the ability to handle the streaming data and guarantees no data loss and guarantees that your events will be delivered in order. And then there is a programming model on top of that that allows you to use pre-built business logic in what we call Apache Malhar. And the majority of these reusable operators, as we call them, are written in Java, although you may write in Java as well as Scala and other languages. And we wrap around this some tools in terms of the DataTorrent RTS Enterprise Edition. So an enterprise class management and monitoring console, a pre-built ingestion application for Hadoop, which I will use later today as a demonstration around batch processing. The ability to create an application without coding using DT-Assemble, and then the ability to visualize your data in real time using DT Dashboard. So this gives you this great view of an end-to-end pipeline processing paradigm, how it's applied to streaming technology, some of the use cases, and then the architecture that it's actually implemented in. So let's dig deeper into another use case. So one of our customers is a Fortune 5 company that provides advertisements out to many mobile devices. And in fact, their use case is that they really need a high-volume, auto-scaling, fault-tolerant system that can process event streams. And they want to solve two problems as part of this event processing. The first is campaign management, meaning when they've met their service level agreement to their advertisers that they've delivered the number of impressions they promised. And secondly, they want to improve the performance of the advertisements that they're placing. So they want to use this idea of dimensional computing to programmatically deliver better ad placements that have better performance. And from an architecture perspective, this organization has about 800 ad servers that are generating 41 million events per second. They're pulling that data in over Flume, where we've created a fault-tolerant operator for ingestion of Flume. They're building and deduping those 41 billion events against 2 days' worth of events, which is approximately 2 billion events. And they're doing that deduplication in about 2 milliseconds. And then they're funneling that data into an in-memory analytic cube where they're doing campaign analysis. And the result of that campaign analysis is it provides them an ad placement strategy. And it took them from a 45-minute service level agreement to the business in terms of updating the ad placement strategy, which was done external to the system previously, to now they have a 1-minute service level agreement for placing ads. They have a real-time dashboard that's fed off of this so they can see in real time the performance of their ads, the click-through rates, and their margins. And then at the end of this, the data is persisted into an Oracle database for offline further analysis. So this is a true example of a Fortune 5 company using a streaming application in an online advertising space. What I'd like to do is give you a quick demo of an IoT demo that is also a real-time streaming use case. So what you see here is an application written on DataTorrent RTS, and this application is connected to many devices. In this case, the IoT devices are storage arrays, such as you might find from NetApp or EMC. And these storage arrays are providing data back to the data center at the rate of about 7 billion events per second. And what you see here is a dashboard where we're doing dimensional computation around 6 dimensions, such as customer ID, product ID, the OS, the software they're running. And what we're doing is we're calculating the aggregate CPU, RAM, and hard drive usage. Now, I'm able to seamlessly drill down into the application and see the data change instantly as I do the drop-down. And the reason that I can do that is because we are creating a real-time cube in memory. And in order to create this real-time cube in memory, we're parallelizing the system very rapidly. And you can see that this application, I started it just before the webinar, has been up for about 30 minutes. It's processing about 500 million events per second, and in those 30 minutes, it's done 880 million events. So let's see what this application looks like. So if you look at the application in our console, you'll see it's a very simple application with 6 different Java operators or 6 different Java functions. One that's receiving 7 million events per second, one that's generating the cube, which is where the majority of the events are being processed. We then aggregate those results, and we calculate an average. And we store those results in a key value store, which drives the application I just shared with you. Note also that because we want to wrap analytics with business logic, in our average calculator, we have an alert capability. And for this particular example, when a customer gets to 80% of their storage usage, we will send them an email to the salesperson to go make sure the customer is interested in buying more storage. And when it hits 90%, we will send a text message to the technical support people so that they can then contact the customer to ensure that there aren't any performance issues. So this is another example, again, of a real-time streaming application. And when you look at this application, one of the key things, in order to handle this type of scale, we will partition this application across our cluster. So while there are 6 pieces of Java code here as functional libraries, when you look at what is actually running across the cluster in physical view, you'll see that we have 160 of these running that are automatically, dynamically have this topology created across the cluster. And so if those 7 million events per second were to increase to 10 million events, as an example, the cluster would automatically grow and would take advantage of the auto scaling. If those 7 million events were to drop to 3 million, the application would return resources back to the cluster. So again, that's an example of our real-time streaming application. Now, the question is, well, that's great, but how does a real-time streaming platform apply to batch data? And so when we spoke to many of our customers, of course, there's many types of batch data, whether that's your customer information, your historical sales database, your support database, maybe you have product configuration, your corporate information, all types of data that's at rest. And there is a need, of course, to process that data in batch to generate reports, to make decisions, and to take action. And when you look at the stream processing pipeline, as a reminder of the one I showed you earlier, as I mentioned, we see these 5 stages of ingest and archive, transform and normalize, analyze, wrap with business logic, issue alert and take action, and then visualize and persist. So that's how the stream processing pipeline works. What we see with most of our customers for batch processing is an ETL process. That's followed by some type of analytics that's typically done either by a data scientist writing SQL queries or creating some type of stored procedure that they run. And then based on the results of that or based upon the report that's generated, they take action. And there's really no reason to wait until the entire ETL process is done to do analysis. And in fact, what we've been working on with customers is to take that analysis and the alerting capabilities and actually do them on the batch data as the batch data is in motion. And in fact, we've been starting to use the term, or our customers have been calling it, fast batch. So rather than doing what I used to call ETL-AA for analysis and action, we do ETAAL. And that allows us to actually take that processing model and use it in a unified fashion for both fast batch as well as stream processing. Now, many times customers will also ask, well, why does that pipeline model make my fast batch faster? Well, it shares many of the same characteristics, if you will, as the streaming capability. In fact, it does require being high performance. It does require fault tolerance. And generally, what changes it the most is your data source. So you still need to do massive data ingestion, but rather than doing it on high velocity data, you're doing it data that's at rest. That data may be a JDBC compliant database, it may be a NoSQL database, it may be flat files. You may be reading off of NFS. And it may be data that's generated every minute, every 5 minutes, but again, not coming directly from the source, but in the form of a file. And so when we look at what makes fast batch fast, there are a number of properties and capabilities of the streaming platform that enable that. Everything from in-memory computing to the way that jobs are scheduled and partitioned, to the fact that the platform processes on an event-by-event basis that is optimized for locality of compute and data. So I'd like to take a second and walk through each of these areas and explain what I mean by them. So the first one, I think almost needs no explanation, right? Everybody understands that in-memory deployment speeds the processing, right? So unlike MapReduce, which is used for many batch jobs today where people are running MapReduce and writing to HDFS, sort of the industry has moved on to fast batch and running everything in memory, right? Whether that is using Apache Apex or DataTorrent or some other solution, more and more the ability to run in memory is being used. And of course, that removes the latency that's associated with disk reads as well as writes. The next capability that drives batch to be faster is a little bit more subtle. And it's this idea of scheduling the job once. And what I mean by that is with the DataTorrent streaming platform, when you create this data flow, it gets scheduled via Yarn one time. And the job will run and read the data, and it will read the data until the data ends. And by the way, this batch job can be programmed to run any time that you want it to, 5 minutes, 10 minutes, or it can be triggered off of a file system and pull in a file system to see if new data has arrived. Now, if you contrast that with something like MapReduce or any technology that uses the MapReduce paradigm, even though they're in memory potentially, they still are slowed down by the fact that they need to schedule every job in terms of map, reduce, shuffle, and providing the output. And so the schedule once property of the streaming pipeline architecture removes any latency from the application that might be introduced by the overhead of multiple shuffles and multiple reduces. Another way that batch becomes fast batch is where you can get your insight on a partial calculation. And so many times, there will be a batch job that is, the end result is a dashboard, but really what somebody's looking at that dashboard is, did something happen more than 10 times, more than 15 times? What's going on? Can I see the report? And many times you won't see that answer until you run the full batch job. But if in your report you were looking for a certain trigger point, did this activity occur more than 15 times? Well, using fast batch and processing at an event level, you know the instant you hit that 15th time. It may be 10% into the job, it may be 20% into the job, maybe 50% into the job. But the point is that as soon as you hit that event that you've been looking for, you no longer need to process. Now, you probably will complete the processing, but you've also asynchronously triggered the activity that you need to have happen based on that immediate insight. Scalability is huge when it comes to batch processing. So many times batch files are very large batch files, right? And they have many different lines and records. And when you look at a non-partitioning solution, that data gets processed sequentially. With a system that does partitioning, you can take a 1,000-line or 1,000-record file, and you can split it up into 1,000 jobs and run all those jobs in parallel. And in fact, our system will automatically scale and will determine how to run in parallel based on a service level agreement. And the service level agreement can be defined in some very basic terms, such as, process 100 gigabytes per second, or process 10,000 events per second. And if the system is not meeting your requirement, again, so you get to define what fast batch is for you, it will auto-partition and auto-scale so that you have a highly scalable system. And then lastly, even when you scale that system, there still is potential latency and performance degradation that can be introduced if your data is not near compute, right? And of course, in a pipeline processing architecture, by definition, your data is in motion. So we're optimized to actually take that data to the compute. And as a developer, as a data center operator, you can actually specify that locality by simply changing a property. So we can actually run the processing on the same Java thread, within the same Hadoop container, within the same Hadoop node, or within the same rack. And so by enabling you to process this data and enable that the locality to move data next to compute, it enhances performance. And what we see with our customers when we go in to help them, which may look familiar to you, is that they're doing this pipeline without necessarily knowing they're doing the pipeline. However, they're addressing this pipeline through multiple products. So they may have an ETL product, right? So that's the ETL part. They may have some analytics as well as BI platforms, right? Doing the AA afterwards. So they're doing this kind of this ETL AA process. And when you start to use additional products, of course, there are teams that run those products. And those teams and those products, they generate data. So now you start to have silos around products, around teams, and around data. And what that means is to do a batch job, you have a batch process that spans not only systems, but also teams. And in fact, one of our customers had a very specific process where they had, again, financial services organization, where they had what they called the transmission team. And that team's job was to actually pull the data in from multiple systems using traditional extract technology. They pull in data from credit systems, debit systems, ACH, even pulling in files that were generated over secure FTP. Then there was a different team that was responsible for the data prep and the data transformation. There was yet a third team which owned the infrastructure. They owned the database, they owned Hadoop, they owned all of where the data came to rest. And then lastly, there's the business user who's trying to get value out of that data. And for this particular customer, we worked with a team that was driving reports, that was issuing dashboards and then alerts based on that data. And so if you look at this pipeline, at an individual group level, you may not actually feel you're in a pipeline, but you are. And each step of the pipeline today might take an hour or two to run, and so you actually have to run this batch job across 4 to 5 different groups. Well, what we did is we actually wrote an application for them, with them, using this data pipeline model, where the data was pulled from each group, where the business logic that was written already in Java was dropped into the platform. And we enabled them to take a process that would normally take 1 to 2 days and reduce that process down to about 1 to 2 hours. And that without even performance optimization. So the idea is that by using this pipeline processing methodology, you can cross platforms, you can cross groups, and you can cross data silos. And the system itself was fully compatible with everything they already had. It wasn't a rip and replace. We actually used their existing data systems, and we actually wrote the data back to their existing data systems. So let me give you another example of batch processing. So this particular organization was creating a big data fabric. What we find is that there's this intersection of how do I take all my data sources and think of them as one sort of array of data technology, and then how do I take all the consumers of those sources and think of them as another array. And when you overlay the two of them, you start to have a big data fabric. And so this particular group was taking data for compliance processing. So they were taking data from mail servers, they were taking financial data from their internal proprietary systems, and from a historical perspective, and they were pulling financial data from external systems. They were doing a massive join of this data. They were encrypting it and archiving it for compliance reasons. They then would run some analytics to ensure that, in fact, the data was in compliance. They would, one use of the application was to provide an alert on the data, but then they would take the data and make it available to other business users, other business groups, and then persist the data for offline processing. So this is an example, again, of using batch processing in a data pipeline scenario. What I'd like to do now is actually show you how DataTorrent can help you ingest your batch data as the first phase of your batch processing. And for that, I'm going to, once again, go to my demo cluster and show you an application that is running. So this is the DataTorrent console, and you can see I have a number of different applications that are running on my cluster. DataTorrent is Yarn-enabled application, so full multi-tenant. Now we have an ingestion application here that I can go ahead and launch. And when I launch this application, it's very easy for me to configure how I'm going to ingest data. I can select from one of my pre-configured data types, Amazon S3, NFS file systems, HDFS, Kafka, etc. And when I select one of these, it allows me to configure it. I can then select the output source. In case of our demonstration, we're going to be ingesting data into HDFS. So I would select HDFS. And I can now also decide if I want this data compressed, encrypted. I can specify how much bandwidth I want used so that I don't flood the network. And I can actually specify parallelization. Now, for our demonstration, I'm actually going to use a saved configuration file. And the series here, you see here, allows me to create HDFS to HDFS. Oops, sorry, I think it need to reset this one so it doesn't get confused. And now when I run this demonstration, I can launch the application. And I launched this application before we started. And what I'm going to do, the application is running now, and this application looks for pulling data. So I'm going to create some data and put it in a directory to simulate data being generated. And what you see, if I go back to the application itself, excuse me for 1 second, if I go back to the running application, I can visualize this application, and I can show you that the data is flowing through it. And you can see here that the application itself splits the file. So we process it in parallel. We send the different data through a block reader and a block writer. We do processing. We stitch the file together at the end, and then we make statistics available out to the organization. And so for me to create a dashboard for this, it's very simple. I just need to go to my Visualize tab. I can create a new dashboard, and so we'll do Ingestion Dashboard for Webinar. And as you can see here, our dashboard capability lets me take data from any application. I'm going to take it from the application that we created. And in fact, I'm going to let it generate a default capability for me. You can see here, I've got a pie chart that's showing each of the files that have been ingested. I've got a multi-bar chart that shows the number of tuples that are being processed, both inside and out. And I'm able to actually go in and make configuration changes. So I can pick a different application. I can pick a different capability. I can name the y-axis and the x-axis. And I can now look at the data as it's flowing. On an application, I can turn off various components of what's being shown. So again, really a quite flexible system to allow you to operationally see which data is being processed, how many files are being processed, and how much data is being moved on a tuple-by-tuple basis. So that is a great example of how you can do batch processing, showing the first half of that pipeline, data ingestion. And of course, you can ingest from many, many sources. That app was pre-configured to show you 5 sources. We have more than 80 sources already out available in the open source. And as I mentioned earlier, this platform is based around an open source technology called Apache Apex. So I think it might be great to have a quick discussion and give you an overview of Apache Apex. So Apache Apex is the industry's first open source enterprise class unified stream and batch processing platform. As I mentioned, it forms the core of DataTorrent RTS3, and it has some key capabilities that are very valuable for both streaming as well as batch, in that it processes events and it provides guarantees on those events. So it guarantees no data loss, it guarantees your events in order, and it allows you to specify at least once, at most once, and only once processing. Everything runs in memory and provides that auto-scaling capability that I talked to you about. It is fault tolerant, so the developer does not have to write any operational code. The system automatically maintains state, and in the event of an error, will auto-restart. We provide the ability to process data natively using a rolling and or static window. Of course, being an Apache project, it's Apache 2.0 license, and it is an incubation at the moment. So if you go to Apex at incubator.apache.org, you can get all the details. In terms of a timeline, Apache Apex was announced June 5th. Code was delivered July 30th. And proposal was made to Apache to take it on as a project, which was approved 5 days later. And in fact, the first release has already been approved and shipped. There's quite an active community around this, as you see from our champions and mentors from some of the biggest and brightest names in the open source community. And from a committer perspective, you know, committers from Apple, GE, DirecTV, Barclays, Silver Spring Networks, etc. So this project has been gaining a lot of momentum, and I suggest that you check it out. And so in conclusion, to talk about the summary of today's activities, we really focused in on the ability of an organization to use both batch and stream applications on the same technology. In this case, DataTorrent RTS and the Apache Apex Foundation. And most organizations do have both batch and streaming use cases. In fact, many aren't even ready yet for streaming, and so they start with batch, and they use this pipeline or data in motion architecture to give them a foundation for both use cases. And the overarching factor or reason for this is that this faster time to insight drives faster time to action, which results in greater business value. I encourage you to take a look at Apache Apex, as well as to check out DataTorrent yourself. And in fact, you can even download a version that runs in our sandbox, which runs as a VM on your local system, or a full-blown version that you can run on your cluster. So with that, I think we'll turn it over to our moderators and take some questions from the audience.
Great, thanks so much, John. All right, so we have a couple of questions that have come through the panel. The first one comes from Steve. He says, I see you're showing linear systems in your architecture. Can you handle multiple stream types and data sources?
Sure. So that is a good question. I think for simplicity, when we show the pipeline processing model, again, we show the 5 stages of ingest and archive, transform and normalize, analyze and provide business logic that enables you to issue alerts and take action, and then visualization and persistence. So we show that as kind of a logical level of the way the data would flow, whether it's streaming or batch. But as I showed in the IoT demo, as well as in the batch demo where we split the file, you can take and create multiple streams, and the system will do that for you very easily on its own. And you can ingest data from multiple sources, both streaming and batch, at the same time within a single application. And of course, you can actually output on multiple streams if you need to as well.
Great. Sandy asks, how do I get my business ready for stream processing? Is there a path some of your customers take that you could share?
Sure, that's also a great question. And I mentioned and touched on this a little bit earlier in the presentation, is that many of our customers are looking for a way to satisfy their batch processing needs, or even sort of that in-between use case where they're generating files and data on a periodic basis, but not necessarily on a streaming basis. And so being able to use a platform like Apache Apex to drive this concept of fast batch is a great starting point. And as an ability to get started, it's very simple because it's an easy download. There are a number of pre-built input adapters and pre-built operators, and an organization can reuse their existing Java or Scala code within an application. So our recommendation is to download it, try it out, and start to build your batch application in a pipeline/data in motion architecture.
Great. All right, one last question just came in. Alex asks, you mentioned fault tolerance. Can you speak a little bit more about how fault tolerance is addressed in the platform?
Sure. So I actually didn't provide a demo of fault tolerance as part of the application today. I can certainly do that. One of the things that is interesting about our platform is that our platform enables you to take a running application and not write any business or any operational logic in it. So this particular application, by the way, is a Twitter hashtag application, sort of streaming 101. And you can see here that we're tracking the top trending hashtags. Now, of course, this is all running in memory, and the application itself has 5 components. The middle component is actually counting the hashtags. And so if that middle component were to have some type of fault or some type of error, you would lose all of the data. And if I look at my console, that middle component is running in container 2 on this particular cluster. So I can go ahead and kill container 2. And what you'll see here is that container 2 will go down, that the containers 1 and 2 will still keep processing because, of course, people are still tweeting. The system will automatically instantiate a new version of the unique hashtag operator. It will restitch that together into an application, and it will rewind the data to the last known good state. And in this way, you can see all occurred while I was speaking. And if you look at the processing, you can actually see where there was a data dip and then a data spike where we caught up and drained that. So I guess that's maybe a longer answer than you may have wanted, Sandy. I apologize for that. But the idea is that the platform itself provides fault tolerance, both for streaming as well as batch applications. So what we find on the batch side is many batch applications today, or batch jobs, are written as a script, and they have individual components. And if any one of those components in the script fails, then you actually have to restart the entire batch processing to rerunning the script. And so with the pipeline architecture that's fault tolerant, there's no need to do that. Do we have any more questions? I see we're kind of coming up to the end of our time. As you can see, my calendar has just popped up.
Thank you, John. That was a great session, and thanks for the fabulous demonstration. At this point, I'd like to wrap up our session for today. And again, thank you everyone for joining us, and thank you for your time and attention and your questions. As I mentioned earlier, we'll be sending you the recording after today's session, so you have another opportunity to view it and ask more questions if you like. But thank you again, everyone.